So here we're going to get an introduction to periodic functions. And with that, we're going to look at a Ferris wheel. And really what we want to do is, with the Ferris wheel, kind of imagining that we're on the ride. We're going around the Ferris wheel and tracking the time that's passing as well as our height off the ground. And with this, we'll get some new terminology to work with as well. So what we have here is our Ferris wheel. It has a diameter of 500 feet. So our diameter is the distance across the entire circle. So we have 500 feet there. It also can be visualized here. So meaning down here we have a height of 0 feet. And up here we have a height of 500 feet. And it's turning continuously. And we're going to go ahead and say it's turning in a counterclockwise direction, just to kind of match with how we work with our unit circle. Alright, it completes a single rotation in 20 minutes. So that means in terms of time, if we imagine getting on the ride, if we're going to start a stopwatch as we go through this ride, that means to be down here, at the very bottom, this has a time of 0. It also has a time of 20 minutes. Alright, and then what we could tie together there when we're getting on the ride is that those two times have a height of 0 feet. So we have time and height. Now let's go ahead and look at what's going to happen when we reach the top. So reaching the top, we'll have a height of 500. And in terms of time, that's going to be our halfway mark. You know, we're starting at 0 minutes. We're going to complete one circle after 20 minutes. So to be at the top there, that's going to occur after 10 minutes. And then what we could do is think about these kind of quarter of the way marks. So for both of these, we want to think about time and height. So for time, this is the halfway mark between 0 minutes and 10 minutes, so that'll occur after 5 minutes. And then for height, we'll be halfway between 0 and 500, so this will have a height of 250. And then on this other side, we'll have a time of 15. And a height of 250. So these are just some key points that we're going to be looking at. You can imagine there's so many other pieces in here, but for now, we'll just look at that. So let's complete this table. If we're looking at these increments of 5 minutes, then mapping the height, so when we're at 0 minutes, we saw we have a height of 0. After 5 minutes, we were up to a height of 250 feet. After 10 minutes, we were at that peak of, 10 minutes, we'll be at the peak of 500. And then we'll be coming back down to 250. And then we'll be back to the beginning at 0. And then you can imagine you just continue going on. So after 25 minutes, we'll be at that same 5-minute mark. So it's like where I have t equals 5, that's also t equals 25. And that'll have the height of 250. And then after 30 minutes, we'll be back at that peak of 500. And then we'll be declining down to 250. And after 40 minutes, we would have completed 2 revolutions. And we'd be back to that height of 0. So let's take those coordinates and plot them on this graph here. So I've set up these axes. So we're going to be mapping height on our y-axis. You can see I just really wanted to see between 0 and 500. And then for time, 0 to 40. Let's just plot these points. 0, 0 is down here. 5, 250. 10, 500. 15, 250. Then back to 0. Then up to 250. 30. 35, and 40. So what you can see is there's these kind of key values coming through. We're seeing 500 come through. Adjust that point a little bit. We're seeing 250 come through. And we're seeing 0 come through. But what we need to do is figure out what's happening between these points. How do we graph the heights? And something that's going to occur is that while we might be inclined to connect this with a straight line, it's not linear. How that occurs is not linear, and we can really see that from the shape that we're dealing with at the beginning. We're dealing with this circular shape. So if you've ridden a Ferris wheel, maybe you can kind of understand this a bit better, but we can also visualize this. So let's just think about when we get on the ride and to this halfway point. There's kind of this drag at the beginning here. You kind of slowly start increasing. Like when you get on the ride, it almost feels like you're going horizontally for a bit. So you're not increasing height very much. And then it kind of switches over and you start increasing height pretty quickly. And then you're increasing height pretty quickly. But then it kind of slows down and you almost feel like you're inching your way to the top. Now time isn't changing. Time is staying the same. But it's like how we approach these heights. It isn't strictly linear, meaning you're not increasing the same amount of height per minute is the idea. You're getting these different increments of kind of different slopes coming through, different rates of change. So it kind of goes slow and then fast and then fast and then slow. So with that, what happens to our graph? So just thinking between 0 and 5, what our graph is going to look like is our height is going to increase kind of slowly, and then it's going to kind of skyrocket up to that 250. And then between that 5 and 10, it's increasing quickly, and then it's going to kind of slow down as we approach the 500. So if we imagine how our height is increasing here, it's kind of increasing slowly, and then that rate of change, if you imagine slope right here, is pretty steep. And then our slope gets less steep, and it's as we approach that peak. And then it's the same in the opposite direction. It's like when you leave that peak, it almost feels like you're going flat for a little bit. So the height's decreasing slowly, and then it's decreasing quickly, and then it kind of flattens out as you get close to your beginning point. So with that, when I connect these dots, it is in a straight line because how these y values are changing is not linear. There's curvature to it. There's different slopes occurring as we go through this. But as soon as we make a full revolution, then it's exactly the same. So then we'd have this kind of flat and then increasing up and then kind of flatten. And then a little bit flat, and then decreasing down, and then flatten out. And then as you can imagine, we'll continue on in that same pattern forever. So this shape right here is a periodic function. Another word you might see is, this word's so tough to say out loud, but sinusoidal. I'll say periodic more often, but periodic, meaning we get this shape, and then it's like we can copy and paste that shape over and over and over until infinity. It doesn't change, like these slopes aren't going to be changing. It's once we can map from 0 minutes to 20 minutes, then we have the rest of the graph. It's going to follow that same trend off to forever. Now with this word problem, we don't really look at negative time, but when we start to get into more abstract cases, we'll see that it also continues in that direction as well. So, with this, the idea is going around the outside of the circle and collecting these basically x and y coordinates, and hopefully you're starting to get a sense of what we're going to be doing next with sine and cosine, and this kind of relationship to these values along the outside of the circle, and translating that to an x and y coordinate system. So, let's talk about some terminology that's coming through here. The period of the graph. So the period is talking about this kind of distance before it starts repeating. So it's really, in terms of the circle, it's the idea of how long does it take to make a full revolution. And visualizing that on the graph here, the idea of, like, our graph is starting here at this point, 0, 0, and then we can see the trend of our graph, and it's doing different stuff, until we get to 20, and then we can see it's starting to repeat. So it's this horizontal distance right here for how long it takes for our graph to start repeating its shape. So for our function here, we would say our period is 20. Or in terms of this word problem, it's the idea of those 20 minutes that it takes to make a full revolution. So reading from the word problem, when I see this, that a single rotation in 20 minutes, that makes me think of the period of the graph. Because then once you have that, you kind of have a scale for your x-axis for seeing one period, and then beyond that, once you can graph everything within that one period, all the other pieces of the graph follow through, because if you have the behavior for what's going on in here, then you know what's happening next to it, and like I was saying, off to infinity. Another term is the midline of the graph, and I kind of drew this with those red dots. Something that's going to be helpful is visualizing these minimum values that come through. So our minimum values are happening along the x or the t-axis there. And we have our maximum values, which are happening up there. And what happens between is our midline, and that also has important coordinates from our graph coming through. So our midline visually is midway between that minimum and maximum value. You can see it on the circle itself as these points that are kind of occurring in the middle of the circle. And this is going to be a horizontal line. So how I would describe it, if I needed to describe our midline, it's a horizontal line. So typically it would be y equals, and then the number for your midline. Here our variable is h, so I'm just going to adjust that. So h is going to be 250. And if I needed units for it, it's the 250 feet. So to visualize the midline, we'll need to think about the minimum and maximum values that are occurring, and then it will be halfway in between. All right, the amplitude of the graph. So this is going to be a vertical distance between the maximum and the midline. So with this, to visualize the amplitude, it's this distance right here. That would be our amplitude. So it's a vertical distance. So this distance between 500 and 250. So if we needed to calculate it, you just take the maximum value minus the midline. It also occurs down here. Minimum between midline, those values should be exactly the same. So you can see the amplitude in two different spots there. So for us, the amplitude, I often write amp just for short. I'll write it out here. Amplitude is that maximum minus minimum. It should always be positive. It should always be positive, as should the period. The midline, however, can be negative, because it can go to a negative part of our y-axis. So our amplitude is 250. So visualizing that on our circle, it's coming through as, where do I want to draw this? As from that maximum to the midline. And that relates to the radius of our circle. So when we work with these graphs, what we'll be kind of doing is relating our circle, which for us is going to be our unit circle, and translating that over, but there's these characteristics that carry over with it. These things that we've been visualizing in our circle are going to transfer over into our graph that's occurring on the XY axis.